So hello again. My name is Carlos Lizarraga, and I'll be talking for Meg and Mitun since they had other issues today. So I'm going to start with their session, and I'm going to share the notes for today. So let me stop sharing this one. And let's see. Okay. So let's start with the Data Lab GitHub. So this is the place where you find all the learning resources, current and past, and we have lots of learning materials, and also you will find a link to our YouTube channel where we do all the recordings are uploaded after we finish. So give them about a week, and then you can find all the recordings for the different sessions. So today is natural language processing, and today we will be looking at October 10th, text preprocessing for NLP, and you will find the notebook for today, but I think I have my version, so let me just find it. If I find it, where is it? Let me find it. So just a second. Yes, here it is. So that notebook is this one. So I already loaded to Google Colab where you can run it. So let's start. So today we are going to do pre-processing for natural language processing by different methods. And the idea is to select some initial raw text and then try to do all the different processes like tokenization, cleaning the text, and then the parts of speech tagging, and also select or eliminate the stop words, and then do the different processes like lemmatization or other processes. And then once we have the clean text, then we can try to use a machine learning model to do some tasks. Okay, so that's more or less the processes we are doing. So we are recording. Yes. So so why we need to do some pre-processing? Well, the reason is that usually the texts we find are maybe noisy. They may contain typos, slang words, some abbreviations, or they can contain some characters that are not machine readable. So we need to do some pre-processing to increase the data quality, also to enhance some model performance, and also at the end reduce the complexity of the text. Okay, so we will be focusing on 4 different cases for text pre-processing. We will pre-process plain text, and then we'll process a web page, and at the end we will see a case how to process a PDF file. Okay, so these are the most common types of text. So let's start with the plain text and what type of tools then we can use and are available to us for doing these type of tasks. So for example, what type of task we can do is converting text to lowercase, or removing punctuation and special characters, or removing numbers, for example. So let's start with this corpus, which is 4 lines of text, and it includes abbreviations like can't. It includes special symbols like this part. Also includes dots. It includes maybe some other things that we want to eliminate, for example, numbers, etc. So to do that, once we have this item defined, or this variable defined, then we're going to use Python library called re and string. And we're going to define, let me increase the, so we have a segment of Python code. We have to import these libraries, re and string. And then we define a function which is called clean text. And this is the argument text. And we are going to be applying maybe lower to convert uppercase to lowercase. We may remove numbers using this instruction. We are going to substitute this is just any decimal number. We're going to replace it by nothing, or just empty space from the text. Another function can be translate some string. For example, we want to remove punctuation. So whenever the function translate string make trans, whenever it finds a comma, it will just drop it. So we were removing punctuation. And then another thing we can do is remove special characters. So this /W will remove any special characters like the exclamation points or pound signs, etc. So this is my function, can do 4 different tasks. And then we're going to take this variable corpus, which is a corpus of text. And then we're going to apply the function clean text to a word, where the word is an element of the item corpus or the corpus variable. So it will just iterate through the different elements of corpus, and we will be trying to clean the text. And this clean text will just convert uppercase to lowercase, remove numbers, remove commas, and also remove special characters. So this is the text that needs to be cleaned up. And then once we run it, oh, yes, I think, yes, I need to run the first one. This is the definition, and then I need to import the libraries. And then once I define corpus in the memory, working memory, then I can do a cleaning. And this is the segment of text that has been cleaned. So it doesn't contain any uppercase, sorry. Oh, come on. It doesn't contain any uppercase letters. It doesn't contain any numbers. It doesn't contain any commas, dots, or even special characters. So this is the converted clean text, and this was the original text that we want to clean. Okay, so it has changed everything. So no. Okay, so that's through these different functions, which are defined in the library re, and also we are working with strings of characters. Okay, now there's another Python library which is called the Natural Language Toolkit, NLTK. Also, it can help you do different tasks for cleaning the tasks. And also, this also can be done using Spacey, and Spacey was seen in a previous session by Meg. So now we're going to import this natural language toolkit NLPK, and we're going to import different functions like word tokenize, and we're going to download these other tokenizers. So we run, come on. We run this cell, and it's just importing the libraries. So now we're going to use the clean corpus that we got up here, this part. We're going to now tokenize, and tokenization means that you want to separate your phrase or into separate words. Okay, so that's the tokenization. So we're going to tokenize the clean corpus text, and so we're doing word tokenization for every element of the word inside the cleaned corpus, and then we're going to print the length of the tokenized corpus, which are going to be 4 lines of text, and then we're going to print every item in the tokenized in the tokenized corpus. And so we execute, and now the previous text, which was this in 4 rows, now is separated by word or token by token, and this was achieved by using the function word tokenize from the natural language token toolkit. Yes, okay. And this is the tokenized corpus. It consists of 4 rows or 4 arrays. This is 1, and then there's a comma separating the second one, so that's 4 times. Okay. Now, what about stop words? We can eliminate some stop words, and these are going to be loaded using, again, the natural language toolkit. So we're going to import the stop words. And if you don't remember what is a stop word, there are, from this library, stop words, there are 179 elements, and these are like words like with, how, he, his, she's, not, why, my. So these are stop words. So we're going to eliminate those stop words from our cleaned corpus. So we load it, and then we execute. So we're going to use the stop words in English, and then we're going to filter the corpus from stop words and eliminate them. So we execute this cell. And now we have the filtered corpus without stop words. Okay, so now remember, this is the text we're working. I can't wait for the new season of my favorite show. And after eliminating the stop words, then we can read can't wait new season favorite show. So now it's simpler, or eliminating those common words, stop words. Okay, so now we have a filtered corpus with no stop words. Okay, and this is the collection of stop words for English. The next task we can do is lemmatization and stemming. And that means that we want to eliminate special endings and just keep the root word of any word that we are going to analyze. So to do that, we import these other sublibraries from the natural language toolkit and stem library. And these are the 2 functions, the porter stemmer and the WordNet lemmatizer. And we're going to download WordNet. Okay. So we define two functions, stemmer and lemmatizer, based on these other functions, the Porter stemmer and the WordNet lemmatizer. And we're going to define a corpus filter by stems and corpus filter by lemmatizer, okay? So it's just, again, a loop that is going to analyze every word in the document, and the document is inside the filtered corpus. The filtered corpus now is the clean text with no stop words. And we're going to do the same thing with the lemmatize. So we're just applying different functions, the stem and the lemmatize. And then we're going to print the result for both actions or tasks. And then you can see the section for stems and the section for lemmas. So stems can't wait, new season favored, and there's no E at the end, show, COVID, pandem, and the lemmas you will find pandemic, for example. Here you will find affect, and here you will find affected. So stems and lemmas are more or less the same thing, except for the different endings, okay? So, and also you may find the same result. For example, news, you will find in both cases. News and news, you will find it in both cases. So some words will stay and some other words may be chopped a little bit, okay? The ending. Okay, so now we have done the lemmatization and stemming. What else we can do? We can handle contractions. So for example, if you have a phrase like, I'll be there within 5 minutes, won't you? So you see that there are two contractions here, right? And so what do they mean? So we need to install this new function library, contractions. We do a pip install, and I'm going to add the quiet. So I know that it works, so I don't need to see all the results. So I'm going to install contractions, and it's installing, and it's done. Okay. Then I'm going to import text wrap and contractions. And then this will be the text I'm going to try to eliminate contractions. So I'll be there within 5 minutes. Shouldn't you be there too? I'd love to see you there, my dear. It's awesome to meet new friends. We've been waiting for this day for so long. Aren't you leaving today? So there are a couple of contractions, so we want to expand those. So we start with an empty list, and we're going to create a new text with no contractions. So, and then we're going to print the original text and print the text without contractions. So these two print commands at the end. And we execute the cell, and now we have the original text and the text without contractions. So that's the function of this contractions library for Python. Okay. So we are trying to automate processes that maybe it's too cumbersome to do on a long text. Okay. So any questions up to this point? Please open your microphone and ask or put it in the chat. Okay. The next topic is the part of speech. So once we have a text, we would like to identify all the different parts of a speech, like nouns, verbs, adjectives, etc. And this can be done using the perceptum tagger, which is like a small neural network. And we're going to download it from the Natural Language Toolkit. And now it's in the working memory. And then we're going to import this part of speech tagger and the word tokenizer from the natural language toolkit. And then we will run this sample text. NLTK is a powerful library for natural language processing. And then we're going to tokenize the words from the text, which is this phrase. And then we're going to perform the part of speech tag on all the words that have been tokenized. And then we're going to print the original text and print the parts of speech tags, okay? So we just execute. So we're now trying to identify the parts of the speech of this phrase. But first we have to tokenize it. So this is the original text. NLTK is a powerful library for natural language processing. And then these are the results. So we have is a verb. I don't know what's a DT, but there is a small list of glossary here. So JJ is an adjective, and in is the preposition, and N is the noun. So you identify, this library has identified each part of the speech. Okay. So this is the libraries you can use for tagging each part of the speech. Okay. All right. Okay, so this is just pre-processing texts to obtain a very clean text that we can then feed into a machine learning model or large language model. And now the text will be clean, and the model will work better with that. What about if we have web pages? And so how can we? Web pages are written usually in HTML and CSS. So a web page will be a combination of these instructions, HTML instructions or CSS instructions, and text. So we want to clean whatever we want from a web page. So we're going to use another library, which is called Beautiful Soup. And Beautiful Soup is a special library to parse HTML or XML documents. So we import Beautiful Soup. And then we're going to define this function, extracts text from HTML, and we're going to give a HTML content string. Okay. And this function, this is a comment. This function searches each HTML tag and returns the contents in a dictionary containing the tag name and the text housed in each HTML tag. Okay, so we start with an empty dictionary, and we're going to build this dictionary from scratch. And this dictionary will be created using the Beautiful Soup library. So the HTML content is going to be whatever web page we want, and we're going to apply this HTML parser, and we're going to extract the text and split it in new lines and full stops, so in order to ease our readability. So we will define the text as the elements that we got from the Beautiful Soup, and then we're going to loop through all the tags and extract the text, okay? And then after we are extracting the tags, the text, we will be adding it into a dictionary. So this is just a function defined, and then we're going to use it in the next step. I think it's the same. Yes. I want to run it anyway. Okay, and then we're going to use an example. So we have this dummy HTML. So HTML doc has a HTML. These are the HTML instructions, head title. The title is dorm house story. This is the end of title, end of header. And from here to the end is going to be the body of the web page, and has some paragraph story. Once upon a time, there were 3 little sisters, and their names were, and has a lot of HTML instruction links. One of the sisters were named Elsie, Lacey, and Tilly, but has all these HTML encoded, and they lived at the bottom of a well, and then end of story. Okay, so this is the text with links, HTML commands, and some text. We are interested only in the text, so we need to clean that. So in order to clean this HTML combination of commands and text, we need to do the HTML parser to this information variable, which is called HTML doc, and we apply beautiful soup to extract all the contents. And we will print all of the HTML tags commands found, and we will print the contents of the page. So let's run this. Okay, so what are the HTML found, tags found? HTML, and this is the text, the dorm house story. Once upon a time, there were 3 little sisters, and their names were Elsie, Lacey, and Tilly, and they lived at the bottom of the well. So the header was dorm house story, and the title was the dorm house story, and the body is this part, right? And so we have extracted the parts of the web page by taking advantage of HTML tags that define the header, the title, and the body of text. Okay. And then we have created also a dictionary. We know that the names of the little sisters were Elsie, Lacey, and Tilly, and they lived at the bottom of the well. So so this process just removes remember the links, the URLs that were mixed inside the text. So we have eliminated that, and also we have eliminated all the HTML tags like beginning of paragraph, beginning of answer, end of paragraph, etc. Right? And so that was the utility of beautiful soup. And then this is another example. We will use a Wikipedia page that contains the letters written by Seneca, which I think is this one. So this is a page over a wiki source, so it's a novel. So this is the content of the letters. So we know that this has links. So if I click here, I will open a new page, and so on. So my text or the contents have links. So I want to extract the contents of the book and eliminating all the links to extract the information I really want. So I go back. So I'm trying to clean that web page from the Wikipedia. So I'm going to import request and fetch an HTML. So I need to give an address, URL, and then it will send a request, and at some point I want to extract the information from Wikipedia. So I'm going to define this function first, fetch HTML. And then I'm going to fetch it. So I'm going to define the URL address of that web page. And I'm going to define the variable source. And then this variable source will get the request. So it's going to pull the HTML file from the web as text. And then we will print a little chunk to see the output. So this cell is just getting the text over the Wikipedia and then printing some part, okay? And did I run everything? Yes. Okay, did I run this one? Yes. Okay. Okay. Maybe I need to, okay, I think this is it. Extract bank text from raw source code. So the HTML parser, I'm going to run it. And this is part of the information that is over the Wikipedia page, the moral letters for Tullicilius, which is this page. Okay. And so this is what I'm getting through this function. And you will find all the different, all the information without the HTML tags and commands. So this is how you get the contents of a web page, and then you proceed to maybe extract more information. Okay, so that's a way you can obtain the information from a web page. Okay, the other case will be extracting information from PDF files. Also, Python has a collection of different PDF files. There is no unique solution. There is no unique function. There's always more ways of doing the same thing. So just have that in mind, that the way we are doing here, you may find other examples in the internet where they are doing something similar. Remember that whenever you're trying to do something, surely somebody already has tried, and many people have done it. So you may find different ways of doing the same thing. So there's no unique answer to any task you're trying to do. Okay, so how can we read the contents of a PDF file? So we need to install this library, Python to PDF. Okay. So, okay, so now I have installed it. And then I'm going to extract information from this document. Actually, I will have a PDF file, but this is just the context of what we're going to do. So it's the wiki entry for Adar. And I'm not familiar with this, but this is the page. Okay. So this is the Lord of the Rings. And we're going to extract names, I believe. So this is the whole settings for the Lord of the Rings. And we're going to process this PDF, which is, let me open it. Okay. Okay, copy. Well, anyway, we will see it. So this is the address where this PDF is sitting on the internet. And we're going to request to get it. And then it's just checking if the file is there or not. And if the file has been downloaded successfully. If not, it will tell us. So let's execute. So if the address is correct, it will get the PDF file and it has downloaded successfully. So now we're going to use the PyPDF2 library to read. Actually, this command here has downloaded the file into my local directory. This is the file. So can I open it? Somewhere. Yes. Okay. No, I don't know where it opens. But anyway, this is we have the file here, and this is the path where it's located. And the path where it's located is simply this one, a dark PDF example. So this is the PDF file I want to process, and I'm going to open this PDF file, reading by blocks using the PDF Py to PDF to PDF reader function. So we are reading the PDF, and then we're going to extract characters from the PDF. So the idea here is to extract page 2 of the document. So I don't know how many pages, but we're going to just select page 2, and we're going to extract, and then we're going to print the contents of page 2, and we're defining some width. So execute, and you get this text of the second page of that PDF document. Okay, it's full of characters, symbols, numbers, etc. So we want to process this PDF. Okay, so I don't know if inside this library it's using an optical character recognition, OCR. And sometimes when you use these OCR libraries, you may get different, optically can be confusing to determine if there's a letter or digit or something may go wrong. So you have to check always. And so what we're going to do is look for typos and spell checkers, and just try to clean this text that is coming from a PDF using an optical character recognition library. Okay, so we're going to use again the Ray library, and we're going to clean, removing all the special characters, and also well, this is the main this will substitute anything, any special thing, but by nothing, just meaning it's going to eliminate all the different special characters. So let's do it. And now we have a text with no special characters compared to what it was previously, right? So here we had some special characters like Morgoth servant here. And down here, we will see, yeah, something the same. Supposedly this is cleaner than we had before, so let's believe it is. Okay, now we can use a pipeline to extract the names containing this text. So there must be a definition of how to extract a name. So we're going to download additional libraries like Maxent, Chunker, Words, and part of speech and tokenizer, and also some tree and red library. So we do that, and somebody, oh, sorry, I pressed the keyboard. Sorry. Okay, so now everything has been downloaded and imported into the working memory. And then this text, the cleaned corpus, we're going to use it here. So we're going to clean the text. This is just a function definition, clean NLTK, and we're going to give a text, and that whatever text is going to be tokenized, identify the part of speech, and also select the named entities, and it's going to be returning the named entities to whatever text we input this clean NLT key function. And then, so we're going to apply this function to the clean corpus from above, and we will get these results, and then we will print the results, okay? So let's do it. And we get these results, okay? So now these are the parts of speech. Refuge is a noun. In, it's the, what, the intersection? No, very bad memory. Nouns, verbs, etc. Right? So these are the parts of speech for every part of the text from above. Okay, and at the end, we will need only the contents of the tree item for each named entity. So the name entities will be extracted from the NLTK results, and we're going to select only which are equal to 3, and we're going to print this named entities separated by a new line, and we execute. So these are the named entities: organization 1, organization 3, organization first, age, Moriondor, elder, days, second, age after, Morgoth, etc. Okay. And I think lastly, we're going to extract person names from the list of named entities. And so we're going to label persons from those named entities, and we execute, and these are the names of the person. First, Adar Orcs, Adar Deer Nost, Sauron, Adar, Dark Lord, etc. So we are able to extract all the names from this original text that we had obtained from the PDF, right? So in this clean PDF file after the OCR, there are some names hidden here, and we are able of obtaining the names, right, automatically using this library or this set of instructions. So you can see that Python has different libraries that you can use to simplify your tasks of cleaning text. And then after you clean your text, then you can feed it to a machine learning model. Okay, so I think that is the exercise for today. And if you have any questions, please let me know. And next week, Meg will resume. And that's my example for today. Any questions? Yes.
In terms of the web page, HTML, is it possible for us, since some of the page they have like multiple page, we want to get the data from like multiple page, can the library in Python help us to turn page?
Cut pages. First, you have to read everything that when you go to a URL, you will get the whole page, right?
Yeah, I think the URL is only for the first page. When you come to the second page,
HTML doesn't have pages. It's just a single HTML file. The browser the browser is an interpreter. It's interpreting HTML commands, so it's creating a page. So if you go to Amazon and you open a page, it's just feeding different parts of a database and displaying whatever you're searching. The URL. Like, for example, in Wikipedia, once you have a URL, like this one, yes. So this is the page, right? So let's go to main page. So this is the contents of this address, and if you print it, you will get these contents. You visually you will get that. But if you say, okay, so if I don't remember how to use it. If I want to see the code, let's see. Remember how to see the code in
F12. I don't know.
What?
It's different on the Mac, but F12.
F12? It's okay. Yes, these are the instructions in HTML and CSS. They are creating visually, or the web browser is interpreting all these set of commands to create this. But when you ask, I'm gonna take this is out. When you ask for a specific URL, which is this one, this is what you get in the printer, but actually the web browser is interpreting all these results, all these instructions to create the page. Yes, because this page, this code at some point is calling different information from a database in order to build the web page. Before, at the beginning of the web, things were simpler, but then as HTML and XML have evolved, now things are more elaborated, but you get a richer page of information. But you need to start with this URL and then apply it. Maybe the function is really working as a web browser, and when you're pulling a URL content, you are pulling down this information. But this information was created by extracting the different parts of the code. Okay. Okay, so let's see if there was another question. Okay. Okay. Yes, you start with a URL, Alan. Yes. Yeah, because the code is just a mess. Well, not a mess, but a set of instructions. Every part of the page has, like, it's going to be a header, it's going to be a footer, it's going to be a body, etc. Right? Yeah, so today, a combination of HTML, CSS, XML, everything is working in conjunctions to create this page visually that we print or read. Okay. All right. So that's what I have today. Thank you for connecting, and we will see you next week in the same channel. Thank you.